Hey, it's Anthony. Welcome back to Project Random. Today's video is going to be about a space probe. Some of you may have heard of it. It's called the Rosetta probe. It was launched by the European Space Agency in 2004, and its goal is to rendezvous with a comet and study it. Now, this is the first time that we as a species have attempted to rendezvous with a comet, mostly because they're kind of small and it's a little bit technical to actually get near one and stay near one and sort of get into orbit with one. It's not much of an orbit. It's more like a controlled flight in circles. But basically, the comet that it recently rendezvoused with, it was launched in 2004, as I mentioned, and it rendezvoused about a couple of weeks ago now with a comet called 67P. Which is approximately 3.5 kilometers by 4 kilometers. So it's a pretty small little object to point out in space. It's located in between Mars and Jupiter, but it's not an asteroid, so it's not in the asteroid belt. It's in a sort of an elliptical oblong orbit. So it comes in closer to the Sun, a little bit closer to Mars, I believe. I'm not positive on that. And then goes back out again and makes this weird sort of ellipse around the Sun. And like I said, it's a comet, so we don't know a whole lot about comets, especially their makeup, because we haven't had the chance to study them other than when, you know, they pass by and we can look at them, for example, Halley's Comet and things like that. So with this comet, the ESA decided we're going to go to it and we're going to get real close to it. We're going to put a lander on it, which is pretty cool. The lander's called Philae, Philae. It's the name of an island in the Nile River. And basically the probe is going to drop this lander down onto the comet, and the lander is going to hook on there because there's not much gravity really per se, because the object is so small. So the lander is going to hook onto it, and it's got a series of instruments. It's going to take some samples of the material around, and basically it's doing a chemical analysis, trying to figure out what exactly the comets in general, but more specifically this comet, is made of, and sort of either to confirm or disprove theories that we have about how the solar system formed and how life may have gotten to Earth, because a lot of people believe that comets were actually responsible for depositing organic molecules and amino acids and nucleic acids, things like that were sort of the building blocks to life. And a lot of people think that if you look at a comet, they may have those sort of materials. So that's something that we're interested in finding out. And comets also contain a lot of water in the form of ice, usually. Well, always, I guess, because they're so cold. So this is another thing that we're looking for to learn, basically, what it is that causes comets to form, how they were formed in the early solar system, and whether or not it was plausible that the comet is actually what brought life to Earth. So it's pretty cool. There's going to be, the probe itself is also doing some different types of spectrometry. I'm not sure what that word is actually, but with light, different wavelengths of light, so infrared and X-ray, that sort of thing. And it's trying to determine the chemical makeup of not only the core of the comet but also the tail, what's coming off the comet, and that sort of stuff. So it's a pretty cool space probe, and we stand to learn a lot from it. So in the coming weeks, the probe is going to move into a closer orbit, about 30 kilometers above the surface of this comet, and from there it's going to pick out a landing spot to drop the lander, and it's going to put that lander down there, and we're going to get all this crazy data back that hopefully confirms what we already think we know. But it's always interesting if we disprove something, because then we can go back to the drawing board and think of new ideas, and science is cool like that. An interesting thing about this comet, I mentioned it was launched 10 years ago in 2004 by the European Space Agency, the ESA. And in order to get up to the speed required to rendezvous with the comet, it's about 19 kilometers per second, or maybe that's 19,000 kilometers an hour. One or the other. It had to go quite quickly. So they actually used an effect called a gravity assist, which basically meant that they launched from Earth and they put it in an orbit around the sun that would make it so that it would pass by Earth again, and it would use Earth's gravity to pass by really close to Earth and then slingshot out the other side, going faster than it came in. And it did that twice around Earth and once around Mars. So there was a lot of, kind of like pinball, I guess, except you don't want to collide. You want gravity to do all the work. You don't want to actually do any physical collisions. But it's pretty cool the way that they kind of designed the flight path of the probe to actually get to the comet, and it all worked out perfectly. The comet is now, like I said, sitting about 100 kilometers above. The probe is sitting about 100 kilometers above this comet, so that's pretty impressive, I have to say. It's not like trying to go to another planet where you just go so close and then it kind of the planet kind of pulls you in and says, "Come here, I got you," and you just had to slow down a little bit because they stood a good chance of overshooting this comet or missing it where it might be, because you've got to predict where that comet is going to be 10 years from now when you're launching in order to actually rendezvous with it. So you're essentially aiming where there's nothing, but by the time you get there, there's going to be something there. So that's pretty cool. For those of you who might be wondering, the cost of the project, total cost, was about 1.3 billion euro. So it seems like a lot of money, but it's not for something, for space travel, I guess. Generally, as an example, the Curiosity rover that NASA, or JPL I should say, put on Mars. JPL is the Jet Propulsion Laboratory. They handle the NASA robotics, interplanetary robotics stuff. That project was $5 or $6 billion. So I mean, I realize that we're probably, it's a lot more complex to put a rover on Mars and land it with a sky crane and have it drive around. It's also the size of an SUV, it's much larger. But 1.3 billion euro to potentially gain all of this new wealth of information from a comet is pretty cool, and it's well worth the investment. People say that space travel isn't worth the money that we're spending on it because there are so many other things that we could do on Earth. And I argue with those people in saying that humans are naturally curious. We want to know how things work, why they work, how did things become the way they are, and through our endeavors into space, we are able to learn things not only about the places we're going, but the places we came from. And I think that's the most important thing we can take away from space travel, is appreciation for life on Earth and our planet in general. So 1.3 billion euros is definitely worth the investment if we have the potential to find out how life began on Earth, how the solar system formed. It answers so many of our fundamental questions that science has been asking for a long time. So hopefully there's a lot of good information comes out of this. So yeah, that's basically all I want to talk about in this video. So I will be back tomorrow with another video. I hope you enjoyed this. Leave a comment, like, and that sort of thing. Thanks for watching.